isn't it? I'm ready for any question you may have. There are still 1, 2, 3 students who did not do any work in MyLabs Plus. That's heartbreaking. So please. Okay, any questions for me? Yes, please.
In order to log into the MyLab or whatever,
Yes, MyLabs Plus.
I bought a book before knowing not to buy one. So do I use the access code out of that in order to get?
Yes,
Okay.
you can. You don't have to purchase an extra.
Okay.
Yes. And you're going to be using the same book for Math 012.
Cool. All right.
So, and the access code
Right.
should be valid for both classes.
Okay.
Good. Anything else? Anything that you worked on and you got stuck on? Any problem? Yes, please.
Yeah, it comes to the equations when this simple one's going a over 6 equals 5.
A over 6 equals 5. So this is, if you remember, we looked at three different topics last time. One topic was, very good, working with fractions. Excellent. The second topic was algebraic expressions, evaluating them. Okay, very good. And the other topic was, the third one?
Order of operations.
Order of operations. So do we have any questions on those? Are we okay with fractions, order of operations, and evaluating expressions?
I have a question for fractions.
Yes.
It's number 10
Okay.
on the quiz preview.
Okay. So you have it up there and we can copy it, correct?
Yeah.
Okay. For quiz preview. Good. I would like to finish this before we look at that question. So here's my question now. What have we studied in Chapter 2? What is the first major topic in Chapter 2? Solving linear equations. These are the simplest possible types of equations. These are the simplest possible types of equations. Okay? So there are several principles here when solving equations. An equation is a balance. So I have 1 pound here and 1 pound here. If I do something to this side, whatever I decide to do to this side, I have to do it to this side. Meaning, if I add 5 pounds here, what do I have to add here in order not to destroy the balance? Now, if I multiply this side by 2, what do I have to do to this side?
Multiply by 2.
Right. We have had this concept before in fractions, right? If we did something to the top, like multiplying by 5, we had to do what to the bottom? Multiply by 5. Here, addition doesn't work. You cannot add 1 to the top and 1 to the bottom and still have the same equation, a fraction. That doesn't work here. Good. So now I'm here, and I have a balance. One side is a over 6. The other side is 5. Yes, please.
Are you going to ask what you're going to do?
Yes.
You have to multiply both sides by 6.
Right. So what is the idea behind multiplying? First of all, I want to eliminate the fraction. And somewhere in Chapter 1, we were talking about multiplicative inverses. Inverses. What does that mean? It means that if I multiply a number, let's say number x, I have to multiply it by something to get 1. If that's the case, if I find this number that I multiply x by to get 1, these two numbers, this number and this number, are called multiplicative inverses or reciprocals of each other, whichever name you want to give it. give them multiplicative inverses or reciprocals of each other. So what will I have here? What can I have? What should this number be in order for the product of x times that number is 1? Let's try with a number, and then we'll come back here. Let's say I want 3. 3 will be multiplied by what to get 1? Remember multiplication of fractions. Let's say we don't know. Let's say we don't know. So this must be a fraction. There's no other way. In which way, if you remember from multiplication fractions, in which way or what number should I have here and here to get the 1?
1/3.
Yes, I have to have 3 at the top and 3 at the bottom. Only 3 at the top and 3 at the bottom will give us 1, right? 3 times 1 over 3 times 1 will be 1. Okay, so now let's try one more time. What about 1/5? What will I multiply 1/5 by to get 1? Or if you want to say 1 over 1.
5,
Over?
1.
Exactly. In other words, I accept 5, of course, because 5 or 5 over 1 is the same thing. Okay, one more. Let's say negative 2/3. What do I need to multiply it by in order to get 1 over 1? Negative 3 over 2, exactly. Multiply 2 negatives, I get a positive. Multiply 2 times 3, I get 6. Multiply 3 times 2, I get 6. 6 over 6 is 1. All these are multiplicative inverses. 3 over 1 and 1/3. Multiplicative inverses. Why? Their product is
1.
1. 1/5 and 5, bless you, and 5 over 1. They are multiplicative inverses. Why? Their product is negative 2/3 and negative 3/2. They are multiplicative inverses. Why? Because their product is 1. Coming back finally to our equation. And this is very important. A over 6 can be rewritten. And I would like you to get into the habit of imagining that at all times. This is extremely important for what follows in algebra. A over 6 is the same thing with, I'm asking now, 1 over 6 times A over 1? That's a question.
Yes.
Yes, right? A times 1 is A. I'm sorry, 1 times A is A. 6 times 1 is 6. So writing A over 6 as 1/6 times A, do we all see that? Why is this important? For many reasons. Let me give you one reason. This number will soon in this class be called the coefficient of A. Plain English, the number that multiplies A. Like in a foreign language, we need to have some vocabulary to be able to express ourselves. So the same thing here. We need to know when we talk about multiplicative inverses what they mean. We need to know when we talk about the coefficient of a variable what we mean. Is the number in front of it. So now coming back here, can anyone give me the final answer for x being multiplied by what to give 1, to get 1? Based on what we discussed here. What could it be?
1 over x.
Of course. Indeed. So x over 1 times 1 over x is 1. These two numbers are inverses of each other or multiplicative inverses of each other or reciprocals of each other, whatever you want to say. Okay. All this theory behind it is important. So finally, let's come back here. That is one of the reasons why when we solve this equation, I personally look at it like this. I meant 6 here, of course, equals 5. And yes, the idea is to get rid of 1 over 6. What is the multiplicative inverse of 1 over 6? So I know what we need to multiply both sides by. Excellent. So 6 over 1 and 6 over 1 on both sides. Remember what I said? If I have a pound here and a pound here, and I multiply this side by 6, I have to multiply this side by 6. So the left-hand side will be, how much is this now? If these two numbers are multiplicative inverses of each other or reciprocals of each other, how much is the product? Always. Exactly. Otherwise, they would not be multiplicative inverses of each other. I choose the one that is the multiplicative inverse of 1/6, so I can get 1. You can multiply both sides by 2/3, but that's not going to do the trick. Only 6 over 1 will do the trick, right? So I have a on this side. I made the coefficient of a to be 1 by multiplying it by 6 over 1. Multiplying both sides of the equation by 6 over 1. I made the coefficient of a 1, and that's what I wanted in order to solve for a. And then the right-hand side is?
30.
We can always go back and plug it in and check the answer. When I plug in here 30, 30 divided by 6 is indeed 5. Does this answer your question? So what are the principles of equations? We can add numbers or terms to both sides. We can subtract numbers or terms from both sides. We can multiply both sides by the same number, positive or negative, but not 0. And we can divide both sides by a positive or a negative, but not what did we say last time? We cannot divide by?
0.
0.
Excellent. Division by 0 is called? Very good. Okay, so is this clear? I know it took me 20 minutes to explain all this because I want you to see the background. And this is, all these are very important. This is a very important concept. That's why we chose 6 over 1, to eliminate 1 over 6. This is another very important concept to understand that if you give me, for example, 2/3 x or 2x over 3, I basically look at it as 2/3 x. Very important to identify the coefficient of the variable. Is this wrong? No. But if I have to work in equations or inequalities, I will look at it like this. Okay, so we are back to number 10, problem 10 from the quiz preview. What was it? What were you trying to do? Okay, so we have negative 14 minus 2 squared over negative 6 times negative 2. So it's negative 6 minus 2?
1.
Minus 1. And negative 14 minus 2 squared like this?
Yeah, but the 1 is in parentheses.
Like this?
Yeah.
Is there another symbol between negative 6 and negative 1? No. Very good. Awesome. Good. So here we are asked to simplify this equation. Where do I start? What do I do first? Yes. However, there is a difference between the parentheses at the top and the parentheses at the bottom. Okay? So this indeed tells me to square 2. Actually, parentheses here are not really required. This is the same thing with this. So there is no operation in there that I need to perform. And this number is not negative. So really, this is not a grouping symbol.
So it's just showing you that you need to multiply?
It just shows you that you have to square 2, but since 2 is not a negative number, you don't really need to do anything. to the parentheses. They will disappear. This situation is totally different from the top. This one says basically this. Again, not a grouping symbol. But why is it important? And this one needs to be there. This one doesn't need to be there. This pair does not need to be there. This pair of parentheses, not required. Here I have no choice. This is a must. Why? Because we always separate two operation symbols. We cannot, this will be incorrect. This is not allowed. So here I have no choice. I have to have parentheses because the parentheses tell me that I'm multiplying -6 by -1. It's a perfect example in which we look at different uses of parentheses. Yes?
I have a question. Before the parentheses, there's a -1 before it, right?
At the top. You mean at the top?
Yes.
In the numerator? Yes. However, because 2 is not negative, they're not required. This is exactly this. So this is correct. If I had this, then I would have had no choice but put parentheses.
So it's up top. It's 14 minus 4.
Exactly. Yes. So I continue here. So this is -14. 2 squared is 4 times minus or -1 in front is indeed -4. Now the denominator is very clear. Once -6, between -6 and -1 in parentheses, there is no operation symbol. It must be product. Otherwise, it would have been addition, subtraction, or division. Since there is nothing, I have to assume it's this. So the denominator would be awesome. And now the numerator is -14 minus 4, which is very good, divided by 6. And the final answer is good. Other questions for me? Anything else?
I do have a question. When you go to my labs class,
Yes?
it doesn't say, it says due date for all of these, 02, 02, 18. It doesn't, do we have to do all of it before?
Are
I have a
you,
question.
very good question. Are you reading my emails in Canvas?
Yes.
I try not to bombard you with 10 emails, but at least one of them you will have that says you must do this between 2 meetings. So in Canvas last week I said you have to get as far as possible in chapter 2 at least to 2.5. No one got to 2.5, but many of you got to 2.4. Others did not do anything. So as I mentioned, 3 students did not do anything in my labs class. I'm very worried. Okay, so what I was expecting today was at least to make progress till here. Many of you got here, which is fine. I'm very proud of you. I'm very happy. Many of you got here. I'm very happy with that too. But I want to have the time to show you examples from this, assuming you're going to also watch the videos, so we don't fall behind. Yes. What am I looking at?
Oh, I'm sorry. We're gonna go over here. All the 2 days. Go to.
Right, because they have to be done by next Friday. That's why I need to finish everything today. Yes, please, sorry.
Oh, I have like a bunch of friends that visual.
Very good, excellent. So can you dictate them?
Did
Did you watch the videos?
Yeah.
Awesome.
Not all of them.
Okay,
I didn't even try to.
but you have to, because everything is due next Friday. So we can review everything for the test. It has a huge component. This class has a huge component, a hybrid, in online. Because we only meet for 2 hours. That's not enough at all. Yes, I'm ready.
Plus 30 over 20 equals 2 over 4x.
2 over
4x.
x here or x here?
Right.
Good. So we're trying to solve.
X plus 30 over 20.
X.
Like the x is by itself.
Oh, like this? Oh, here? Okay. Is this correct now?
Yeah.
Okay. So let me read it one more time so make sure. X plus 30 over 20 equals 2 over 4x. Correct? Okay. So we are asked to solve this equation. How do I know it's a linear equation? And you can say, oh, we never studied anything else. True. But how do I know it's a linear equation? So the indication is this, or several indications I have, several pieces of information by looking at this equation. How do I know it's linear? Again, this is part of our vocabulary. We have to understand when we say linear, we know what it means. When we say quadratic, we know what it means. So how do I know this is linear? There is no x in the denominator. X does not have something at the top, 5 over x. So there is no x in the denominator. That will not be a linear equation. What is the power of x in this equation? Or the exponent, we say, or power?
That's 1.
1. And there are no other variables. For example, an equation that has x times y equals 4, although x is at the top, not in the denominator, although x has power 1, but the fact that it's x times y equals a number is not linear. Okay? So 3 pieces of information I have by simply looking at this. No x in the denominator, x has power 1, and there are no products of variables in which x is part of it. Okay, or the variable, whatever I'm looking for. So I know it's linear. Here's my next step. I see 30 over 20. I'm allowed to divide both top and bottom by the same number in any fraction. I'm allowed to divide both by the same number. I divided the top by 2, I divided bottom by 2. I simplify the equation. There are several keywords in algebra.
Excuse me, how did you get 30?
That was the equation I was given. This was something I thought it was. Sorry about that. I should have deleted it. Okay? So one keyword that you should always have in the back of your mind is simplify. Always try to simplify everything you work on as much as possible. The smaller the numbers, the easier it is. The second keyword that I cannot really add today, but it's part of the course, and it will follow you. These two will follow you in anywhere you go with you. These two will go with you anywhere you go in math. Factor. The bigger meaning of factoring will come up later in the semester. Okay? So these are the key words. Always keep this in mind. Simplify and factor, simplify and factor, simplify and factor. Okay? Good. So then I have x plus 3 over 2 equals 1 over 2x. Can anyone tell us what is the coefficient of x here? 1. Can anyone tell us what is the coefficient of x here?
1. Oh.
Careful. The coefficient. I'm not asking about the reciprocal yet. I will in a minute. But what is the coefficient of x here in this expression?
It's 1. No.
So when we have a over 6, we imagine that it is actually 1 over 6 times a. So the coefficient is everything that I see in front of a, not just one portion or the other. Is that okay? So then the coefficient is indeed 1/2. Good. So now, what do I want to do? Yes, I can move terms around if I want to. But what I would rather do is what?
Three over 2?
I want to eliminate fractions.
Yeah. That's what I
Period.
figured.
Not just one.
Okay.
Fractions. I want to eliminate fractions. Good. How do I do that? What will be the least common denominator And how many fractions I see? I see 3 fractions. I see a fraction with a denominator of 1. I see a fraction with a denominator of 2. And I see a fraction with a denominator of 2. All these terms have a fraction. They have to. What would be the least common denominator of 1, 2, and 2?
It's 2.
2. Awesome. So then I will multiply everything by both sides, each term by
2.
exactly. However, I would write it as 2 over 1. Why? Because I have those fractions in here. So multiply by 2 over 1, multiplied by 2 over 1, and multiply by 2 over 1. So, can anyone give us a simplified form of the first expression? First term. So these are 3 terms. We know the difference between term and factors from last time. So they're all terms. Can anyone give us the simplified form of the first term? What should I write?
It's 2.
Right. But now I can eliminate the 1 in the denominator. So what? The whole term, not 2x. Very good. Plus, like we did with fractions last time, I will simplify by 2.
2.
Yes. And equals. Like we did with fractions last time. I will simplify by 2. So it's x. Any questions?
I have a question.
Sure.
Are you solving the same thing on the top? Is it the same question you're solving?
This one?
Yeah.
This one change into this, and now change into this. Very good. So finally, my next step. How do I continue solving this? What will be my next step here? I'm allowed to move terms around. So if I have here 6 pounds, and I have here 6 pounds, I can remove 2 from both sides, and I have 4 and 4. So I could, because I need to have the variable on one side and the numbers on the other, right? So I need to make sure that this term moves here and make sure that this term moves here. Why? Terms with a variable have to be all of them on one side, and terms without the variable have to be on the other side. Are we okay with this so far? So what I recommend, yes, you can write minus x, if that's what you're used to writing. I'm fine with that. What happens here is when you try to move this term here, you only change its sign. So you don't really have to write minus x and minus x unless you want to. Okay? So this term has a positive symbol in front of it, otherwise it would be negative. So when I move it to the other side, it's becoming negative. Or you write negative x, negative x. I want to move away from that, unless you want to use it. I'm fine with it. So when I move x to this side, it becomes negative. 2x minus x is x. When I move this number from here to the other side, yes, you can write this. I want to move away from that. You're moving it to the other side. And this is the final answer. You can say, I don't trust this. Fine. We go back and check. Okay? So back to the original problem. Here's our original problem. I'm going to copy it. We claim that the simplified form of the answer, or the answer if you want, is -3. I'm going to replace here x by -3. I can still simplify 3 over 2 and see what I get. This is -3 over 1. We studied this last time. How do I add 2 fractions or subtract 2 fractions? It doesn't matter. They don't have the same denominator. So the least common denominator is
2.
very good. This one doesn't need anything, but this one needs something. What does it need?
1 or 2.
2. And this one, if you want, is 1. Can anyone give us the top of the outcome?
-3. -3.
Yes, I have a -6 and +3. Awesome. Indeed, I get -3 at the top. I agree. -3/2. So the left-hand side, when we replace x by -3, it becomes -3/2. We agree? Now I have to check what? If the other side, when I plug in -3, becomes what? Say it again.
-3/2.
Exactly. Otherwise, -3 doesn't work, right? So I plugged in -3 on one side, and I simplified the expression to -3/2. I have to plug in -3 on the other side, and if that simplified form is also -3/2, then the solution is this. If I don't get the same number on both sides, then this is wrong. Are you with me, everyone? Yes? Please ask. So this is our equation. This is our solution. We are trying to see if it works. So I plugged in -3 here, and I got -3/2. I have to plug in -3 here and see if I get -3/2.
I still don't understand how you got -3.
Which one?
Yeah.
This
When you eliminate,
this one?
yeah.
This -3. Okay, very good. So let's go back. Is this step here from here clear from here to here?
Yeah.
Okay. I move x to the other side. How much is 2 apples minus 1 apple? 1 apple. So I move 3 to the other side. It becomes negative. Or you subtract. Or you subtract 3 from both sides, and that's all you get.
So you do it 2x minus x equal to 3.
3 move to the other side is -3.
So hypothetically, say x had
Okay, let me write those steps if it's not. Yes, of course. -x, -x. X plus 3 equals 0. So far, so good? -3, -3. X equals -3. So far, so good? I want to avoid writing this long procedure because I want you to progress and make you move forward. It's not a wrong method. It's a legitimate method. It's fine. But I would like us to move away from this. It takes too long. Yes, Chris.
So are you saying when a term or whatever goes across an equal sign, it switches
Its
the
sign.
sign? That's all you need to remember?
Exactly. Look, so it was +3 here.
Then it's -3
Exactly.
on the other
Exactly.
side. Okay.
So it's +x here,
It's negative x when it goes on the other side.
and I don't have to write all this. Look, from here I can write the solution directly. Instead of writing all this, nothing wrong with it.
Mhm.
But I want us to make progress.
Yeah, that confuses me too when I write it out. Like it seems better at the time, and then like I ultimately botch something in it, and I'm just like.
Again,
That's
I'm
wrong
showing
answer.
different methods, and everyone should choose the method they are comfortable with.
Okay.
I'm fine. Is this better now? Okay, my pleasure. Always stop me if you have questions, anytime. Okay, so we are here. We still have this side as being -3/2, but we don't know if this side is -3/2 just yet, right? So I have 2/4, which is 1/2, and multiplied by -3. This is wrong. I have to either put it like this or put it in parentheses. So it's indeed -3/2 is the same thing, so I'm going to say yes. I checked. It works. I took -3, I put it back in both sides of the equation, I got the same number. It's the only solution, the only number that will make both sides be the same. You cannot find another. Are we okay with this? Are the other problems pretty similar? Because I don't want to do 10 problems the same. Are the other problems the same type? I'm sorry? Okay, is there another one that you would like to work on, or is the idea clear now? Yes.
You want to look at it, this is a lot.
Can I copy it? Very good. So solve the equation for x. It's a very good problem. Thank you so much for picking that because I was going to pick one like this. So we have 9 x minus 3 in parentheses over 6 equals 3 x plus 8 divided by 13. Very good, Vic. Thank you. This is not a trivial problem. Still a basic type of equation, the first level ever, but it's not a trivial equation.
Is this 9 or 8? It's 9.
9.
Oh,
You mean here?
yeah.
This is 9.
Okay.
This is 8. Sorry about that. Okay. We talked about something very important last time. Let me remind you. Super important. How did we define a proportion? What did we say a proportion was? Make a list of concepts. Make a list of concepts in a little notebook. So for example, this is a suggestion I have for you, something like this. Okay, something like this, and write, okay, this is a new concept, proportion, and a little example. This is another new concept, coefficient of a variable. And what is it? Multiplicative inverses. What does this mean? Oh, it's a product of blah, 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 and it gets 1, and these two are multiplicative inverses of each other. This is very important. And you have to look at these till they finally get into your bloodstream. They're new words, new concepts, right? It takes time to absorb. So what is a proportion again? It's a crucial concept, and I need it now. Can anyone give us an example of a proportion? Yes, please.
Just like this, we have
So a fraction on one side, the equal symbol, and what else on the other?
A fraction.
Another fraction. This is a proportion. Why is the proportion so important? Because only in a proportion there is something we can do, but it must be a proportion, otherwise we can't do it.
cross multiplying.
Yes. So in your little notebook, you should write proportion. I can only cross multiply only if it's a proportion. Okay? So please, that's the only way to remember these things. So here's what I do in a proportion. But only if it's a proportion, right? AD equals BC. This is a proportion. So I am going to cross multiply. So let's write it together slowly. So I have 9, I have 13, and I have parentheses. 9 times 13 times parentheses. Numbers first, outside. They're waiting. And then 6 times 3 times x plus 8. Okay, what now? Suggestions, please.
You times the 9 by 13.
Of course. That's my first step. I have to multiply this and I have to multiply this. Is it 117? Correct me if I'm wrong. What now? What are we going to do next? And this is another very important concept.
So it's 117.x.
Not point, but times. Yes. We are using what is called the distributive.
Property.
Yes. Or law. Or property. What does that mean? It means that we multiply the whatever it's in outside the parentheses, we multiply it or we distribute it to all terms inside parentheses. Okay? So these are two terms. 117 must be distributed to both terms. Same thing here. These are two terms. 18 must be distributed to both terms. So 117x minus, because 18x plus
Is that one?
I'm sorry.
What? 18x plus.
So 18 needs to be multiplied by x and 18 multiplied by 8. 117 multiplied by x, 117 multiplied by 3. Correct my numbers if there is anything. Are we okay so far? Good. Now we are back in the same position where we were before, right here. You can write minus, minus, plus, plus, minus, minus, plus, plus, whatever you want to do. I prefer saying I'm going to move 18x to the other side, and I'm going to move negative 351 to the other side. This goes here, and this goes here. So 117x exactly minus 18, and 144 exactly plus 351. So what do I get? Is it 99x equals? Is it 495?
Yes.
Then you divide both sides.
By?
99.
Right. Why do I divide both sides by 99?
Because it has the variable.
Because the coefficient is 99 of x, and the other reason is the multiplicative inverse of 99 is
1,
over.
99.
Exactly. That's why I divide by 99. Because I'm basically multiplying everything by this, which is the multiplicative inverse of 99. So then I get x equals, and how much is 495 divided by 99 is 5. What will you do now if you have doubts about your work?
We plug it in.
Plug it in both sides and make sure that both sides simplify to the same quantity, no matter what that quantity is. If when you plug in 5 in the left-hand side, you get 15, what should you get on the other side if you plug in 5?
15.
Right. Otherwise, the solution is not correct. Or maybe you messed up something else. Good. Very good problem. Thank you. Good. Anything else? Is there anything else you would like to go back to? Is there anything else you would like to go back to?
There's this question I want to bring up. I
Yes.
think I have a slight idea, but let me bring it up.
Sure.
Wait, where's the answer? There we go. Number 11.
Negative 7 over 10 plus 1/2. Okay, we're trying to find the least common denominator for these two. Can anyone give us the factored form of 10?
5, 2.
Yes. 2 times 5 in prime numbers. Awesome. 2 is just 2. Now the least common denominator. How many different factors we see? How many different factors we see here?
2 and 5.
Exactly. What about their powers? Which powers will you keep them with?
1.
Both. Exactly. So the highest power for 2 is 1. Therefore, I carry the 1. The higher powers for 5 is 1. So obviously, the least common denominator is 10. Any necessary adjustments for the top of the first fraction?
So how I find this, the way I find the least common denominator is totally different from the way you explain it.
I'm fine. As long as you know what you're doing, I'm fine. And you show me the method and it works, I'm fine. The reason I'm presenting this method is because of what follows in 012. This method is basically the method we use when we add and subtract rational expressions. So that's the reason why I present this method. If you know another one, you will have to switch at some point in time. I'm fine for that. But in order to understand what happens with rational expressions like these ones, for example, 1 over x minus 1 squared plus 1 over x minus 1 times x plus 3. This is the method that I will show for something like this. Other methods could mess you up. So be careful. Okay, so what is the adjustment for the top of the first fraction?
Multiply by 1.
Exactly. Or you can say nothing, but not 0. Okay, so what about the second fraction?
1 multiplied by 1. No.
By 5.
By 5.
Very good. So then what will you tell me to write? Don't perform the operation. I want everyone to see. What will you write here first and then the final answer?
So 7.
Careful.
Negative.
Negative 7 times 1, which is negative 7, plus 1 times 5, which is positive 5.
Oh, so I've been thinking. Okay, so I had it wrong. So negative, both affects each other. That negative sign affects the 7 in the denominator as well.
Very good question. We discussed that last time. Minus in front of a fraction cannot be carried to the top and to the bottom. So minus in front of a fraction line always goes to the top. And you cannot, because if you use minus and minus, then you change the fraction into a positive. So the minus in front acts like the minus in front of parentheses. Okay, always goes to the top. So negative 7 plus 5 is
-2.
good. And now a negative over a positive is a negative. I'm sorry. And now we simplify by 2.
Negative 5.
Negative 1 over 5.
Oh.
That's why, that's another thing. Thank you for saying that. That's why I always put the 1. If you don't put the 1, you may say that the answer is 5. So every time you simplify and you get a 1, write that 1. I've seen it in so many different papers. Students write this.